Okay, so let's have a look at the Leaving Certificate Higher Level Maths Paper 1 for 2015, and we're going to have a look at the last question on this paper, which is question 9. So we have a question here that has to do with the length of the day in Galway measured in hours from sunrise to sunset, and we have a function here that calculates the length of the day. So f of t is the length of the day, where t is the number of days after March 21st. And we're expressing 2 pi over 365t in radians, which is important. So you got to make sure your calculator is in radians. First thing we've got to do is just use this formula to find the length of the day in Galway on June the 5th. That's 76 days after March 21st. Okay, so we've just got to write the formula down again. So we've just got to write down f of t is equal to 12.25 plus 4.75 times sine 2 pi over 365 times t. Now this is just a direct use of the formula, so what we've got to do here is write down 12.25 plus 4.75 sine 2 pi over 365. we've got to multiply that by 76. Remember, 76 is t, the number of days after March 21st. Okay, so when you do this, you get 12.25 plus, you can find the sign of this on your calculator. Make sure your calculator is in radians. Multiply your answer by 4.75 and you get 4.587. After that, just add these two together and you get 16.837. That's the length of the day. So you want your answer in hours and minutes. So in this case it's going to be 16 hours, and then you've got 0.837 of a day. 0.837 of an hour, I should say. Of an hour. Well, there are 60 minutes in an hour, so you got to multiply this by 60, and to the nearest minute, that's 50 minutes. And that's it, really. That's the first part. In the second part we're going to do something similar again, but this time we're kind of going to be working backwards. So we have to find the date on which the length of the day is 15 hours. So we're given f of t, and we've got to work out what t is. So let's write down our formula again. So f of t is equal to 12.25 plus 4.75 sine 2 pi over 365 times t. So this time we know f of t, so we're working backwards here. So we got 15 here, we got 12.25 here, we got 4.75 times the sine of 2 pi over 365 times t. So you got to work backwards to work out what t is here. First thing I'm going to do, subtract this from both sides. So when you subtract that from both sides, you get 2.75 is equal to 4.75 sine 2 pi over 365 t. Next thing I'm going to do, get rid of this thing here, divide both sides by 4.75. That gives you 11 over 19 is equal to sine 2 pi over 365 times t. Okay, that's as far as we can go really in terms of getting rid of things from the right hand side. So next thing we've got to do is, we have the sine of something is this number here. So to find out what the something is, to find your angle here, you just got to do sine inverse. So in other words, we've got to get sine inverse of 11 over 19, you can do this on your calculator, is equal to 2 pi over 365t. So sine inverse of 11 over 19 is 0.617 617,437, and that's equal to 2 pi over 365 times t. Okay, so let me just come up here now. We want to work out what t is. So this fraction here is multiplied by t, so divide both sides by this fraction. So you end up with t is equal to 35.87. 35.87. In other words, this is 36 days. So we're looking at 36 days after March 21st. So what's that? Well, you got to know how many days are in each month. So there are 31 days in March, and so we go from 21 up to 31. That's 10 days. That gives us 26 days then in April. So we're talking about our answer here then will be April the 26th. That's it. That's the answer to that part of the question. Okay, next one then, we've got to find the derivative of our function. So let's see, our function then is again 12.25 plus 4.75 sine 2 pi over 365 times t. Now let's find our derivative then. F dash of t is equal to, well, if you get the derivative of constant, that's 0. Get the derivative of this thing here is going to be 4.75, and then sine, if you differentiate sine you get cosine. It's going to be cosine of what's in the bracket, 365 times t. However, because this is not just simply sine t, it's sine of something times t, you've got to use the chain rule and differentiate what's inside the bracket as well. So in other words, we're going to multiply all of this by what's inside the bracket and differentiate it, I should say. So differentiate this, what's inside the bracket here is just going to be 2 pi over 365. So you know, if you have 3x and you differentiate it, you get 3. So you have some number times t and differentiate it, you just get that number. So let me just tidy this up a little bit. It's going to be, I'm going to put this, I'm going to take this and just put it in here. That's usually where you put it. And when you do that, you will get 4.75 times 2 pi over 365 times the cosine of 2 pi over 365 times t. Now just to tidy up this coefficient here, when you multiply 4.75 by 2, you will get 9.5. So our answer is 9.5 pi over 365 times the cosine of 2 pi over 365 times t. And that's it really. This is our answer here. I mean, really this is our answer here, but we just need to tidy it up a little bit because we may be using it later, so try and tidy that up. Okay, so next part, hence or otherwise. So usually you go for the hence bit, but there are actually two ways of doing this that I can think of. Hence or, find the length of the longest day in Galway. The length of the longest day. Well, our original function was f of t is equal to 12.25 plus 4.75 times sine 2 pi over 365 times t. Now this function is at a maximum. This is a sine function, and the sine function is going to look like this. And remember, sine functions, they'll start here. This is your x and y axis, and they're at a maximum. Sine is at a maximum here when the sine is 1. It's at a minimum here at minus 1. So sine functions, this part here, the sine of this this part of our function here will be at a maximum at 1. So in other words, what we're looking at here is 12.25 plus 4.75 times 1. This, the maximum that this can be here is 1. So that will just give me an answer of 17 hours. So the length of the longest day in Galway is 17 hours. Now another way of doing that is to look at our derivative here, this part here. So if you differentiate a function and you get the slope of any tangent at any point t in this particular case. Now at our maximum, our slope will be at a maximum, at any maximum here, the slope will be 0. So if we let this equal to 0, work out t, that'll give us our time. That'll give us t at a maximum. So let's do that first. This is kind of a longer way of doing it, but we just take our differential, our function differentiated, which is 9.5 pi over 365 cos 2 pi over 365 times t. Now we want this to be equal to 0. This is the slope of at any point on our function, on our original function. Now at a maximum then this will be 0. The slope will be 0, and a minimum indeed, but we're looking for the maximum here. So let's see, first thing I'm going to do is we've got to work out what t is. So for this thing here, this part is multiplied by cos, so I'm going to divide both sides by this here, and that will give me cos 2 pi over 365t is equal to 0 divided by this here is just going to be 0. Okay, so that's it. Now our function is going to be at a maximum then, as I say, when this is equal to 0. So now we've ended up with cos 2 pi over 365t is equal to 0. So the cos of what angle will give me 0? Well, it's going to be pi over 2, or 90 degrees. The cos of 90 degrees will give me 0. So in other words, this thing here must be 90 degrees, or we're dealing in radians, so it's pi over 2. So in other words, this 2 pi over 365t must be just simply pi over 2. Okay, so let's just work out what t is then. Well, if you look at this function here, you've got, or this equation I should say, you've got pi on the top here, you've got pi on the top here, so we can divide across by pi because everything is multiplied on the top. Let's just cross multiply now because we've got a fraction equal to a fraction. So 2t times 2 is 4t, and 365 times 1 is just 365. That will give me t is equal to, divide both sides by 4, you get 91.25. So this is 91.25 days after March 21st. That's not what we were asked for. We were asked for the length of the longest day. So in other words, we now have t. So to find the length of the longest day, we need to put in 91.25 into our original function. So again, that's going to be 12.25 plus 4.75 sine 2 pi over 365 times 91.25. So now we'll work out the length of the longest day here. So that'll give me 12.25 plus, when you can do all of this on your calculator, do the sine first, multiply all this out first, get the sine of it, and then multiply your answer by 4.75. You'll get 19 over 4. When you add these two together, you also get 17 hours, which is what we got in the using the other method. This method is a lot longer, but it's just a different way of doing it. Okay, so let's look at the next part of the question. This is actually the last part. It says use integration to find the average length of the day in Galway over the next 6 months from March 21st. Give your answer in hours, minutes correct to the nearest minute. So this is an average integration kind of question. So if you remember, what you do here is you just need to get 1 over b minus a, and you've got the a here, the b here, and your function here. So this is what we're doing. It's this average function formula, this average of a function formula. So in our case we have, let's see, what are we going to do? We're going to do 1 over, now we're talking about 184 days from March 21st, so it's going to be 184 minus 0 day is, that's just my phone. Okay, so we got 184 minus 0. 0 is March 21st, and we're talking about 184 days later. So we got 0 to 184, and now we've got to integrate our function, which is 12.25 plus 4.75 times sine 2 pi over 365t. Okay, so this is what we want to integrate. Okay, so let's start. So we got 1 over 184 anyway. So let's integrate this. Well, integrate 12.25, you get 12.25 times t. Now integrate, this is a sine function here. So integrate sine, you get minus cos. so it's going to be minus, and it's going to be 4.75. I'm just going to leave a little bit of a gap here because I know it's coming up, and then I'm going to put in cosine 2 pi over 365 times t. Now if you think about it, what we've got here is, by the way, we're integrating between 0 and 184. If you take this part here, if you differentiate this, you will get 4.75 sine 2 pi over 365 t times 2 pi over 365. Now there isn't an extra 2 pi over 365 here, so we don't get what we started with. If we were to check this and differentiate it, we won't get this. There'll be an extra 2 pi over 365 here, multiplied by this 4.75. So we've got to allow for that. So you've got to, in other words, put in the inverse of this is actually going to be 365 over 2 pi here. Now let me just show you what I mean here. So this is what I'm saying I get when I integrate this here. So in other words, if I differentiate this, I should get this. So if I integrate this, I get this. So if I differentiate this, I should get this. So if we take it, if I just do it down here, 4.75, just don't worry about the signs for the moment, 365 over 2 pi cosine 2 pi over 365 times t. So this is what I'm saying my answer is here when I integrate this part here. So let's just differentiate this. If you differentiate all of this here, you get 4.75 times 365 over 2 pi. Differentiate cos, you get minus sine 2 pi over 365 times t. Now because this isn't a cos of t, it's a cos of 2 pi over 365, you're going to end up with an extra 2 pi over 365 here when you differentiate this part here. Now this is all correct, with the exception of the sign here. Don't worry too much about the sign. The numbers here are all correct up as far as here, but we have this extra 2 pi over 365 here. Now, so all of this is multiplied here. However, I put in this extra 365 over 2 pi here so that this will cancel with this will cancel with this. Now I end up with 4.75 sine 2 pi over 365t, which is what I do get here. Okay, so this is actually the correct integral of this part here. Right, let me just get rid of that and continue on with the question. So we have all of this to do now, so let's see. We have 1 over 184. Now what we have to do now is substitute in the 184 and the 0 and subtract them. So this is going to be quite big. Let's see, we have 12.25 times 184 minus 4.75 times 365 over 2 pi cosine 2 pi over 365 times 184. That's the first part. We've got to subtract. Same thing again, but substitute in 0. So it's going to be 12.25 times 0 minus 4.75 times 365 over 2 pi cosine 2 pi over 365 times 0. And that's another bracket here, and then our big bracket here as well. Okay, so you can see this is kind of big, but hopefully it should just simplify down nicely. Okay, so what we end up with is, we end up with here, we end up with 2254. So we'll end up with 2254 here. This part here we will end up with, this is minus, the cos of this thing here is going to be minus, so we'll end up with a minus minus, which is plus, and then we'll end up with 275. Well, actually, you know what I'll do? I'll just leave in the minus for the moment. So it's minus 275.9349. That's this bit here. And this bit here then we will get, so I'll just put it in here. That's this bit here and this bit here. I'm doing them separately, okay? So the cosine of this thing here will be minus 0.9996666, and I've rounded it then to 7. So that's the left hand side here, and then the right hand side of this subtraction is going to be, when you do all of this again, maybe do it, this is going to be 0 anyway, so this is going to disappear. So do the cos, and this is going to be the cos of 0. Cos of 0 is just 1. So really you've just got to do, you'll just end up doing this bit here. This is going to be the cos of 0, which is 1. This is going to be 0. So this part here just simplifies down to minus 275.9349. Okay, so let's see if we can finish this off. We have 1 over 180, and then, okay, so you got to do all of this. You can just do that on your calculator. This is minus minus, which is plus. Sorry, this is actually 184, I think, is it? Not 180. 184 here. This is 184, this is 184. So this all simplifies down to 2805.777817. Just a lot of tedious calculations here, but just follow it through and you'll get there in the end. You end up with 15.2488, and this is time. I think this is use integration to find the average length of the day. So we're talking about time. Give your answer in hours and minutes, correct to the nearest minute. So this is hours first of all, so we need to change that to hours and minutes. Well, it's 15 hours anyway, and then so it's 15 hours, and we have 0.2488 of an hour as well. Well, there's 60 minutes in an hour, so we get 15 minutes as well to the nearest minute. Okay, so as I said, there's a lot of kind of tedious, long-winded calculations there. Just be careful, just have confidence in what you're doing and keep going till the very end. And even if you do make a little mistake here, along here somewhere, finish it off and you'll get most of the marks anyway. Okay, so that's it for the last question. In fact, that's it for paper 1 for 2015.